Hello students, in this lecture let us discuss the chapter friction. Whenever two surfaces in contact slide or tend to slide, roll or tend to roll over one another, an invisible force comes into existence which opposes the motion. This force is called as frictional force and the phenomena as friction. The cause of frictional force is the interlocking of the minute projections on the two surfaces in contact, and the direction of this frictional force is always such as to oppose the intended motion or the actual motion. Now, in this chapter, the most important topic or term is the limiting friction. The frictional force has an important property by virtue of which it can increase itself with the applied force. However, it cannot increase itself beyond a certain value, and this maximum value of frictional force is called as limiting friction. Now, if we plot a graph of frictional force versus the applied force, the graph looks like this. When the applied force is 0, the frictional force is also 0. And if I increase the applied force P, the frictional force also increases. At certain value of applied force P, the frictional force becomes maximum. And this maximum value of frictional force is called as limiting friction. If hereafter, if there is a slight increase in force P, applied force P, the frictional force cannot increase itself, but it decreases by a small value, and thereafter for any increase in value of applied force P, the frictional force won't change and it remains constant, and the graph appears to be horizontal or parallel to this applied force line. So up to this maximum value of frictional force, that is limiting friction, the body will not be put into motion, it remains stationary, and the friction experienced is called as static friction. Whereas after the frictional force attains the maximum value, if there is any increase in applied force, the frictional force remains constant, it appears horizontal, that is parallel to the applied force line, and here this zone is the motion zone, means the body is actually in motion. So limiting friction is the maximum value of frictional force. Now I am considering that this body, there is this certain body which is kept on a rough horizontal surface, and let P is the force applied to this body. If I draw the free body diagram of this body, I can see these forces acting on this body. The applied force P, the self weight of the body will be acting downwards. This horizontal surface will offer a normal reaction or resistance, a reaction, that is N, and there will be a frictional force F which will be opposing the intended motion. So at every contact surface, two forces are arising. One is the normal reaction, another is the frictional force. So which are the forces due to contact? The question is there any relation between these two forces? Yes, there is one relation between these two forces, and which is always constant for the given material. If we take the ratio of frictional force to the normal reaction, then for given materials it appears to be constant, and it is denoted by mu. Mu is equal to F upon R. F is the frictional force, R is the normal reaction. So you can denote it by N also. So F upon N is mu. Mu is the coefficient of friction. Unit of F is Newton. Normal reaction is also in Newton. So mu is unitless, it is a number. Now angle of friction. As I told you, at contact surface there are these two forces N and F which are arising because of contact. Now N is the normal reaction, F is the frictional force, and if I get the resultant of these two forces, let S be the resultant. The magnitude of S can be obtained as S is equal to root of N square plus F square. Whereas if I denote the angle between the resultant reaction S and the normal reaction N as phi, then tan of phi is equal to F upon N. But F upon N has already been defined as mu, so it is equal to mu. So phi is the angle of friction, mu is the coefficient of friction, tan of phi is equal to mu is the relation between the angle of friction and coefficient of friction. Now the next term which is to be defined over here is angle of repose. Now in order to define the angle of repose, what I am doing is that I am keeping or I am considering a body which is kept on a rough horizontal plane. So it is a body which is kept on a horizontal plane. And if I make this horizontal plane as inclined, or if I go on making this plane inclined and inclined to the horizontal, means if I go on increasing the angle of inclination with the horizontal, a stage will be reached at which the body kept on that inclined plane will be in a position to move down that inclined plane, and the angle made at that stage by the inclined plane with the horizontal is called as angle of repose. So angle of repose is that angle made by an inclined plane with the horizontal at which the body kept on it begins to slide down that inclined plane. Now dry friction. Dry friction is the friction which takes place between two dry surfaces, means there is no fluid in between the two surfaces. There are certain laws which are related with dry friction. The first law is that the frictional force which is existing in between the two dry surfaces is independent of the area of surfaces in contact. Second, the frictional force is always proportional to the normal reaction. And third, at low velocities, the total frictional force is independent of the velocity. So these are the laws which are to be remembered. Now the question on this type which may appear is like this. Suppose there is a certain body which is kept on a horizontal plane. Let the mass of this body is 2 kg. The coefficient of friction between these two surfaces, let it be 0.4, and let a force P is equal to 2.8 Newton, which is applied parallel to this surface. And the question is, what is the frictional force over here? So frictional force is to be obtained. Now in order to get the frictional force over here, we should know in which stage the body is there, whether it is in this zone, that is equilibrium zone, or whether it is in this part, that is motion of the body is taking place or not. And for that they should clearly mention the state of this body. Let us consider that the body is in equilibrium, and I am plainly saying that the body is in equilibrium and mu is equal to 0.4. If a body is in equilibrium, means whether this stage or whether the body is in between these two situations, or will it be at this position. Now when the body is at this situation, it means that it has reached the limiting equilibrium, but they are saying that it is in equilibrium. Now I can use the law or use this formula, mu is equal to F divided by N. Now the question is, when this formula is to be used, and when I use this formula, what is the meaning of this? Now when I use this formula, mu is equal to 0.4, N is the normal reaction. In order to get normal reaction, I will have to show the weight. Weight is equal to, mass is given as 2 kg, so weight will be 2 into 10. I am considering G is equal to 10. So 2 into 10 is 20 Newton, and that is why the normal reaction N will also be equal to 20 Newton. But these two forces are vertical, and these two forces will have no effect along the horizontal direction, and this force F will be acting in opposite direction as that of the intended motion. If I go with this formula, mu is equal to F upon N, then I can get F is equal to mu into N. N is 20 newtons, mu is 0.4, so it is 8 Newton. So by using this formula, I am getting F is equal to 8 Newton, but it doesn't mean that this F is equal to 8 Newton. Now they have said that the body is in equilibrium. If I use summation Fy is equal to 0, I am getting N as 20 Newton, and if I use summation Fx is equal to 0, then I will be getting F is equal to 2.8 Newton. So F is equal to 2.8 Newton by this formula. Now the question is, is this value correct or is this value which is correct. Now, so it is to be noted that when we use this formula, mu is equal to F upon N, means we are considering the stage of limiting equilibrium, means the body has reached this stage, means the value of frictional force is 8 Newton. It is the maximum value of frictional force when we get it from this formula. Now we know the important property of frictional force. Frictional force increases with the applied force. So if P is equal to 2 Newton, F is 2 Newton. If P becomes 4 Newton, F will become 4 Newton. If P becomes 8 Newton, F will also become 8 Newton. But if P increases beyond 8 Newton, F cannot increase itself beyond 8 Newton, because that is the maximum value of frictional force here in this case. So this formula is to be used only when the situation is of limiting equilibrium or the body is on the point of motion. Whereas here equilibrium, we will have to consider summation Fx is equal to 0 and F is equal to 2.8 Newton will be the correct value of frictional force. So this is how the problem on this type is to be solved. We will have to always check in which stage the body is there. Now in the next part, this is the first part of friction. In the next part, I am going to discuss ladder friction, wedge friction, belt friction, etc. So please stay connected, and if you haven't subscribed, please subscribe to my channel. Thanks.